this is carbon and the organic compounds. This is for you 12th graders. I know that you're very upset about the cancellation of your SAT. My advice for you is to go on. There will be an SAT 2 in June, and then there will be replacement SAT on August 29. And if you want my opinion, still apply as you planned for colleges. Colleges have been informed by the College Board about the changes in the SAT dates, and they are going to be compassionate due to the current events. So please apply for the SAT 2, and please take your test, and please prepare for the August test, and then before that apply for colleges. Apply for colleges as soon as you can, as soon as things are better, and then please, colleges are going to wait for you to complete your papers up to October, so you can apply now and then have your SAT. But don't be lazy, don't be depressed because of the cancellation of the SAT. I know many of you depended on it in order to complete the trip with all of the SAT work, but still colleges are going to be compassionate with you because of all of the changes that have been happening, and this is all gonna pass. For the time being, let's concentrate on your GPA. So today we're talking about carbon and organic compounds. I already introduced this session to you in the classroom. We're still going to learn about it, and then we will complete the whole chapter. So why are we talking about carbon? As we said, carbon is present in your water bottle, and it's present in diamond. So it can be as flexible as plastic and as hard as diamond. Why? Because carbon atoms, first of all, they all nearly always form covalent bonds. Three factors make the bonds that carbon atoms form with each other unique. First, even a single covalent bond between two carbon atoms is quite strong. In contrast, the single covalent bond that forms, for example, between two oxygen atoms, such as in hydrogen peroxide, is so weak that this compound decomposes at room temperature. Hydrogen peroxide is the bottle of fluid, or as we call it, the oxygen that you get in order to dye your hair. Second, carbon compounds are not extremely reactive under ordinary conditions. Not extremely reactive means that they are quite stable. Third, because carbon can form up to 4 single covalent bonds. Okay, carbon is the chemical element with the symbol C, of course, and the atomic number 6. So this means that it has 2 electrons on the first energy level and then 4 electrons in the next energy level. Having 4 electrons in the next energy level means that it's ready to complete this level with 4 electrons. So it can form up to 4 bonds, which is very important because it is related to many of the properties of carbon. Let's look here. Let's look here at the allotropes. Okay, the allotropes, they are different bonding arrangement. So if the arrangement differs, this will yield a different compound. So what are the allotropes of carbon? We have 3 carbon allotropes that are very well known. One of them, of course, is the graphite. We have the diamond, and we have the fullerene. Okay, we will start with the graphite. In the graphite, of course, you know the graphite is very soft. The graphite is the lead that you have in your pencil, and you can totally write with your pencil. So the lead allows you to write, and this is the graphite that you have inside your pencil. It's very soft. The carbon atoms in the graphite are bonded in hexagonal pattern, and they lie in plane. So they are bonded in hexagonal pattern, which means that they are 6 carbons together, and then they are arranged in different planes. Okay, the covalent bonds in each plane are very strong. So the covalent bonds over here are very strong, but at the same time the weaker forces hold the planes together. So between the atoms here on the same plane, they're strong, but between the different planes the forces are weak. This is why the graphite slips on the paper and you can write with it. Another type of allotrope of carbon is the fullerene. The fullerene is also a form of carbon allotrope. Okay, how is it formed? As you can see here, the allotrope fullerene is spherical. It's a near spherical cage of carbon atom. The most stable of these structures is C60, which is formed by 60 carbon atoms arranged in interconnected rings. Then we have the diamond. The diamond, of course, it is the hardest known substance. The diamond contains enormous number of carbon atoms that form an extremely strong tetrahedral network. What is a tetrahedral network? It means that each atom has 4 bonds, 1, 2, 3, and 4, as you can see them. Here they are. These are the 4 bonds that are formed around each of the carbon atoms in diamond. What did we talk about here? We talked about the allotropes, which are the different arrangement, the different structural arrangement of carbon, making it unique. Now we're going to talk about the organic compounds and the hydrocarbons. Most of the compounds of carbons, they are referred to as organic compounds, and most organic compounds have atoms of hydrogen. As an example, of course, of organic compound, we have oil. In addition to hydrogen, many other elements can bond to carbon. These elements, they include oxygen, nitrogen, sulfur, phosphorus, and halogens. These bonded atoms are found in the different types of organic compound found in living things, including proteins and lipids. So we have carbon and hydrogens. So we have carbon in the elastic bottle, we have carbon in the diamond, and we have carbon in the carbohydrates, lipids, and proteins that are present in your body. More than 12 million organic compounds are known, and thousands of new ones are discovered or synthesized each year. There are more known compounds of carbon than compounds of all the other elements combined. Okay, so the chemists started collecting these compounds according to their characteristics and according to the arrangement of their atoms. The simplest class of organic compounds are the hydrocarbons. The hydrocarbons means that this is hydrogen and carbon together. This is the most famous of the hydrocarbons, which is the alkane group. In the alkanes, they have carbon atoms that are connected only by single bonds. We have 3 examples here. As for we have, for example, the methane, the ethane, and the propane. Okay, if you look at the structural formula for these 3 alkenes, you're going to notice that each member of the series differs from the one before it by 1 carbon atom and 2 hydrogen atoms. Look here, we have CH4. Over there we have C2H6, so 1 carbon atom, 2 hydrogen atoms. Propane, C3H8, so we have 1 carbon atom difference and 2 hydrogen atoms different from the one before it. This is for the alkane group. Then we have over here the alkenes. Okay, the alkenes contain at least 1 double bond between 2 carbon atoms. Because the alkenes with 1 double bond have twice as many hydrogen atoms as carbon atoms, their general formula is written CnH2n. So if the Cn, so C, if it has 2 and then H2n, it is going to be H4. So it's going to be, for example, for ethane, it is going to be C2H4. So again, for the alkenes, they are the second class of hydrocarbons. It contains 1 double bond between 2 carbon atoms, and then the rest are hydrogen atoms. What is the structural formula for them? It is C2H2n. Okay, sorry, CnH2n. It's CnH2n. So if it's C2, it is going to be H4. If it is C3, it is going to be H6. Then we have, look here, the alkynes. The alkynes are the most reactive hydrocarbon compound. They produce extremely high temperatures while burning. The alkyne contain at least one triple bond between two carbon atoms. So for the alkanes we had one, it was single bond between the carbon atoms, and then for the alkenes it was one double bond between two carbon atoms. For the alkynes we have one triple bond between the carbon atoms. And then we're going to talk now about the carbon atoms when they form rings. Carbon atoms that form covalent bond with one another, let's look here as the different structures. The carbon atoms can be formed in a hydrocarbon can contain one carbon atom as in methane and thousands of carbon atoms as in cellulose, of course. But these are straight chains. Here we can have branched chains. Why do we have all of these arrangements? Because of the millions and millions of compounds that are formed by carbon. So the scientists, in order to study them, they arranged the arrangement by structure as the allotropes. And now we're going to talk about the different chains. Are they straight? Are they circular? Are they branched? And this is a different way to collect all the elements of carbon that are present. Okay, so carbon has an ability to form branches with other carbon atoms. Simple branched alkanes often have a common name using a prefix to distinguish them. All of the alkane, as you notice, they end with "ane" at the end. Okay, the carbon atoms can be arranged in rings. Okay, they can be arranged in a straight line or a ring structure. They also can be branched. For example, 4 carbon atoms and 10 hydrogen atoms, they can be arranged to form butane, which is C6H10, which has a linear structure, which means that it is straight. 4 carbon atoms can also form a compound called cyclobutane, which is C4H8, and it has a ring structure. So the carbon atoms, they can form a straight structure or it can be circular. We have an example of butane as a straight structure, and if it's circular, it is going to be cyclobutane. Benzene is one of the most important ring compounds. Let's look here. Here we said that we can have a straight chain, we can have a branched chain, and we can have ring or cyclic. Okay, one of the most important organic ring that is the hydrocarbon benzene. Remember, benzene structure is C6H6. It is the simplest member of a class of organic compounds which are called aromatic hydrocarbons. One of the most important characteristic of aromatic hydrocarbons is that they have a specific smell. You totally know the smell of benzene when you smell it. Some of them, they are used in insecticides. These compounds, they have a variety of practical uses, from insecticides to artificial flavoring. Benzene can be drawn as 6 carbon rings with 3 double bonds. So the organic compounds that are in the form of a ring here, we only talk about benzene because it's one of the most important one, and it's one of the aromatic hydrocarbons. Here is one of the aromatic hydrocarbons. This is the benzene. Okay, it is one of the strongest types of aromatic hydrocarbons. It's the most famous. And most of the aromatic hydrocarbons, they have strong aromas, they have a specific smell. Okay, let's talk about fossil fuels. 3 types of fossil fuels are the coal, the petroleum, and the natural gas. The primary products of the complete combustion of fossil fuels are carbon dioxide and water vapor. Here we have the substituted hydrocarbons. What is a substituted hydrocarbons means? Here, these are hydrocarbons which have a functional group. What is the functional group? Like most organic compounds, urea contains a group of atoms that is responsible for its chemical properties. Many common organic functional groups can be seen. Because single bonds between carbon atoms are rarely involved in most chemical reactions, functional groups which contain bonds between carbon atoms and atoms with other elements are often responsible for how an organic compound reacts. Organic compounds are commonly classified by the functional group they contain. So here we have a functional group that is responsible for the properties of acetone. A functional group in an alcohol is a hydroxyl group, which is an OH. A functional group in an organic acid is a COOH. A functional group in an amine is amino group. So what is the functional group? It is a bond between carbon and a group that is different from hydrogen that is going to yield a new compound, and this functional group is responsible for the behavior of this compound. So for example, for the alcohol we said that the functional group is OH, and it's or the hydroxyl group, and it's responsible for the actions of alcohol. Okay, we're going to stop here today. We're going to continue talking about carbon and organic compounds in the next session. Please check it in your book. It is present in your book in chapter 19, section 1.